Hey everyone, thanks for joining. Today I'd like to do a quick demonstration of parametrics inside Cameo Systems Modeler or MagicDraw. Parametrics are how we can use math constraints in our model, and it's actually a lot easier to do than you might think. Sometimes I think the name parametrics scares people just a little bit, but it's actually fairly straightforward. So what I'm going to do is start with a very simple system architecture here, and our first step toward creating a parametric diagram is not actually to create the parametric diagram, is to figure out what types of constraints we'll be using. So let's say, for instance, we had a constraint on this system, and we would like to add up two different prices of components that this is made up of, for instance. So let's say that this component is made up of a part, and we'll call this one part 1, and it's made up of another component named part 2. Now both of those components will make up this component 2. And what I'm going to do is add a value property to this to say part 1 has a cost of, let's say, 5, and of course that could be in dollars, but we'll just say it's a real number for now. And then let's say the part 2 has a cost of $10. What I'd like my parametric to do is actually add these two numbers. Now that's very straightforward. The first thing we'll do is use a constraint block here. So we'll just call this a sum. And the most straightforward way to do this would be to say that the total cost equals cost part 1 and cost part 2. Now I'm making up these variables, and you can do that because that's really not important. As long as you don't have spaces in there, you should be good to go. So we'll say cost of part 1 plus cost of part 2. After you've created your equation, what you'll do is use this option to parse and create parameters. Now these are the parameters of the constraint. So the next important part of this is to think of the context, because we could create a parametric diagram inside of the system level block, and then we delve into the architecture from that point. But because we're adding these up to the component level, we could add this constraint to be part of component 2. So I recommend dragging a constraint block onto a block, and if you notice, it now has a constraint property that's called constraint 1, and it's typed by this sum block, or the sum constraint block. So the next part of this will be to create a parametric diagram inside of this component. As I mentioned, you could also create the parametric diagram inside of this block, but you don't have to. So we'll right click on this component level block, we'll say create diagram, and go to a parametric diagram. At this point, Cameo asks you, what would you like to bring into this parametric diagram? We'll bring in part 1, part 2, and also the cost value properties. And then we'll go ahead and check all of these parameters of the constraint property as well. And I'll go ahead and zoom in here a bit. And all you have to do at this point is connect up all of your value properties to your parameters. So to do that, we'll use a binding connector. A binding connector sets things equal. So we'll say that this parameter is equal to this value property by selecting binding connector, connecting that to cost, and then going to cost of part 1. And now what you're seeing here is we forgot to actually incorporate a total cost. So total cost would probably be at the component 2 level. So what we'll do is we'll add a value property of at the component 2 that's named total cost, or we could call it total cost of parts. And that is what all of this will add up to, and that's what that constraint will calculate and output as this value property. So once you're inside of a parametric diagram, if you don't have values displayed, what you can do is right click in your diagram and go to display and say value property. and anything that's not currently displayed that's a value property of the block that owns the parametric diagram will then be displayed. So we'll use a binding connector again, and now we're ready to run our simulation. So we can run our simulation from this block, tell it to run. It says, would you like to load validation rules? And we'll say yes. And if we notice, we have an output here. Total cost of parts is 15, which is what we were looking for. Now that's an easy way to go about doing that. There's actually some slightly even easier ways to go about doing this. So let's bring in a new constraint block on this block diagram, and we'll call this sum also. Sum2, we'll just call it sum2. And in this case, we will use an expression, and we'll say total cost of parts equals sum, and you can use this sum operation. We'll just say sum of x, and x will be our parameter where we bring in all of our values. But in this case, one thing that you need to pay attention to is that x will be bringing in more than one value. So when that's the case, you actually need to set the multiplicity of the parameter to allow more than one, because it defaults to 1 in the simulation, meaning even if you have multiples connected to it, it will only recognize one of those. So we'll go and we'll set this to, you could do 1 to many, or 1 to unlimited, or just an asterisk, which is essentially the same thing as 0 to unlimited. So we'll set that, and then we'll add this constraint to our component 2 as well. And notice we've added that. It is now a constraint property owned by this block. We'll delve back into the parametric, and I'll go ahead and delete these binding connectors here. And we'll go ahead and do a soft delete on that. And now let's bring in our other constraint property. So we'll go to display again, constraint property, the one I just got rid of. I'll have to delete again. And then notice I'm not showing any of my parameters here. So what you can do is either go to parse and create parameters. Since we've already done that in the block diagram, all we have to do is display the parameters. So we have total cost of parts, which we will connect to that value property. And then because we allow more than one input to this, we can now connect more than one value to that parameter. And when we calculate this with the simulation, we should get the same result. So total cost of parts, 15. And if we were to change one of the costs of the parts, let's change this one to 20. Notice it auto recalculates. So that's one of the great things about parametrics, is that anytime anything changes, everything is recalculated. And that's different than if you were to be doing math constraints or equations and activity diagrams. And one thing to note is when it's best to do a parametric versus using math inside of an activity. And if you ask yourself the question of whether or not you want everything to recalculate anytime any of those values change, and the answer is yes, then you probably want to use a parametric constraint. However, in a lot of occasions, you'll do constraints inside of an activity because you actually only want to do that calculation at a certain point in time. So as your activity would progress, you say, now at this point, I'd like to take in these parameters and output a specific value. So that's one good thing to keep in mind as to when you would actually want to use a parametric versus doing math inside of an activity. There are a whole plethora of other functions that you can do that are built into Cameo, and a lot of those are listed in the user guide for Cameo Simulation Toolkit. So if you do not have Cameo Simulation Toolkit, you can get to that by going to Help and then looking at other documentation, and it's built into Cameo where it says Cameo Simulation Toolkit User Guide. That will open up as a PDF, and then somewhere around page 412, you get into all of these different functions that you can use that are built in. So these are very, very nice to use. Notice we have absolute value of x. Any of those things would return values. You could do arc cosines, arc tangents, different types of trigonometry functions and things like that. One thing to also note with some of these is the way that they're calculated when it gets into functions such as those trig functions like an arctangent is that they are actually doing their math behind the scenes slightly differently than you would see in Excel. So if you are trying to take in something that you had in Excel where you're using some type of an arctangent, for instance, or an arc cosine, you'll actually have to modify what the equation would be in Excel to Cameo. And the nice thing about it is Cameo actually builds in a lot of that functionality into these functions, whereas Excel leaves some of that to where you have to add to the function. And there are things like dividing by 180, things like that, that you'd actually do at the end in Excel that you don't have to do in Cameo. So that's one of the nice things, but also something good to keep in mind if you're trying to copy formulas that you would have in Excel directly into Cameo. So that's a quick overview of performing parametric simulations inside of Cameo. If you have any questions or would like to see any other types of examples of this, please let me know, and I'd be happy to do a little demonstration of that. Thanks for watching.